Hi everyone, today I'm going to talk about quantum computer. You may have heard about quantum computers. Richard Feynman argued that in order to analyze the movement of the microworld, there would have to be a computer based on Schrödinger's equation, which is starting point for quantum computers. Since then, quantum computers are increasingly likely to be realized in line with the progress of miniaturization of memory chips and spintronics. As memory chips are miniaturized to nanounits, the effects of quantum mechanical transmittance and interference become severe, and semiconductor memory had technical limitations such as data being volatile when current was cut off. Therefore, using the characteristic that spin of electrons does not change by itself without other objects to give or accept energy, quantum computers that overcame the volatility of data by using electrons as an operator has emerged. Spintronics is a compound word of spin and electronics, which refers to the technology that regulates the spin of electrons. Spintronics are also being used for next-generation memory such as MRAM and hard disks. Even now, methods to control the spin of electrons in stable manner are being actively studied, and studies such as Barytronics have produced notable results. There are many kinds of quantum computers depending on how they are constructed, such as QED quantum computers, quantum dot quantum computers, ion trap quantum computers, and nuclear magnetic resonance method quantum computers, and so on. Quantum computers use qubit as basic unit of computation, which is an electron with two directions of spin at the same time. This makes the difference between quantum computers and classical computers. Do you know what the quantum computer is different from the classical one? When you think of quantum computers, you probably think of fast speed. But this is both true and false. Electrons in an atom has less external effect and have quantum entanglement and overlaps. These characteristics allow them to perform various operations at the same time, reducing the speed of computation. Actually, quantum computers and classical computers are complementary rather than alternative ones. Let me explain further. The classical computer is a deterministic Turing machine because it has a linear and deterministic system that puts one result on one input. On the other hand, quantum computers use the non-deterministic system of quantum particles, so we can express many cases with small number of qubits and produce various results at once. We cannot exactly know what operations are performing in the qubit until the measurement is finished. In addition, expressing quantum as a probability wave function can deal with a problem with mechanics much faster because conflicting states are offset and incorrect answers are eliminated quickly. As quantum computers and classical computers have different fundamental operating principles, the direction in which quantum computers are expected to be used is different from the classical computers are doing. It is expected that quantum computers will play a role in dealing with non-deterministic NP problems. It will be able to handle problems relatively quickly that do not have standard solutions that apply like formulas, even though various causes and factors must be considered, such as traffic situation analysis, optimal route finding, market analysis, and complexity analysis. However, quantum mechanical systems can be weaker than classical computers in irreversible transformations because they always change in unitary way. In fact, the D-Wave, considered the first commercialized quantum computer, was sold in 2014, but there is no news yet that it has shown outstanding performance. In addition, D-Wave is hard to call a complete quantum computer because it is in the form of a normal computer reading again what quantum CPUs have done. So it seems still take more time to create a quantum computer that can handle the computations we want, but it also seems certain that someday quantum computers will be commercialized, so it will be nice to have time to think about what quantum computers are like and how they will be used. Thank you for watching my video till the end.